Welcome to another session. Here I have another problem which is little bit different. We have another one same as this one in exercise 1.2. So I want to combine these two in a single session. So it looks hard, but the concept is very easy. Let me explain how you can solve in no time. Okay, let's start. So first I read the problem. Consider the numbers for n where n is a natural number. Check whether there is any value of n for which 4n ends with the digit 0. So this is what the problem is. To solve the problem, I write the what is the number 4n. The number is 4n. What is given means, so n is a natural number. So natural number means like starts from 1 and 2, it goes on like this. This is what natural numbers. So what we need to check, for any value of n, the answer will come, right, for some numbers, that whether that ends with 0 or not. For example, I take some number like that ends with 0, 50 or 100, 1000, anything. So all numbers are ends with 0, right? So here, if any number ends with 0, that must be divided by 5. So that must be divided by 5, right? So that 5 will be the one of the prime factor, right? If any number ends with 0, the 5 must be the one of the prime factor of that particular number. So here what we are going to do, we are going to check whether the 4n has the prime factor of 5. Whether the 4n has the prime factor 5 or not. So if in this case 5 is one of the prime factor of 4n, then that number, then 4n must be end with 0 for some particular n value, right? So first what are we going to check? The 4n has the prime factor 5 or not. This is what we are going to check first. So I want to split 4n like this. So 4n to raise to 2n. So both are same. So we can write 4n as 2 the whole power to 2n. So both are same. So here you see, here we have 2, right? So in this case, 2 is the only factor. So in other way you can split like this. So 4n equals 2 into 2. Okay, so see, look at C. See here, 2 is the only factor for 4n. No other factors. So if there is no factor of 5, so if there is no factor, 5 is a prime factor, then this number will never end with 0. So what is the conclusion? If 5 is not the factor of any number, it will never end with 0. Okay. So 4n, our given problem, will never end with 0 for any number of n, any natural number of n. This is what our conclusion is. So here is another problem which is similar to the previous one. Check whether, from exercise 1.2. Check whether 6n can end with digit 0 for any natural numbers n. So the same rule we are going to apply here. What is the rule? If any number ends with 0, that must be 5 as a prime factor. So this is our rule, right? This is what we applied in previous problem. So next step, what we done? Next we need to check this 6n has the factor of 5 or not. So for that I want to split this 2 into 3 in n. So for here, see, it's clearly, you can clearly see 2 and 3 is the only factor of 6. So no other factors. So 5 will not the factor of this one, right? So it clearly shown 5 is not the factor of 6n. So our conclusion is, so 2 and 3 are the only factors of 6n. So since 5 is not the factor of 6n, it will not end with 0 for any value of n. So here, sorry, here not the whole power, sorry, I did mistake. So 2 into 2 into n, this is how you write. Okay.